If you can't see them, I can highlight them for you. Just so you can see how many sides there are. I find it easier to count the number of vertices. However many vertices there are, that's how many sides there are every time. So if you can't see from far away, I'll give you another minute. So you find out how many sides there are, and then you use the formula to find the sum of the measures of the interior angles. You also label this classwork 1-10. To begin. Alright, so we did this yesterday. So if you do not know how to do the bell ringer, I'm going to show you right here. The sum of the measures of the interior angles of a convex n-gon. So, the word convex, don't let that throw you off whenever you see this. What is the opposite of convex? Concave. So concave means some of the points are pointing inward. The reason convex is so important is all of the angles are pointing outward, all the vertices. And so the formulas work for convex but not concave. So if you see that word, pretty much ignore it. But the formula is n minus 2 times 180. What does the letter n represent? The number of sides. So here it's 6. So you'd plug in 6 minus 2. Where did they get that minus 2 from?
The ones right next to it.
The what? Why do you subtract 2? You do subtract it from the number of sides, but what are you finding, Kobe?
You said like why you subtract 2, right? Because that's how many triangles you know.
That's what?
That's how many triangles.
That's how many triangles there are. So what happens is, however many sides there are, minus 2, that's how many triangles there are. Multiply it by 180 degrees, because 180 degrees is how many fit in one triangle. So multiplying it by the number of triangles will get you the overall measure in any polygon. Okay, so it just shows you this is always the formula. Alright. The second part is called a corollary. It just means like it piggybacks off of the interior angles theorem. And it deals with quadrilaterals. Okay, how many sides does a quadrilateral have? 4 of them. And there are many kinds of them. Rectangles, squares, kites, rhombuses. And then there are some that just have, like they're ugly. Like that one. That's not anything really. It just has 4 sides. So it makes it a quadrilateral. So yesterday we talked about it. How many degrees fit inside of a quadrilateral every single time? 360. Okay, so it's a corollary, meaning if you learn this one, you don't have to show the work for it. It just would be simple for you. You see 4 sides? They add up and equal 360 degrees. Does that work for 5-sided, 6-sided, 7-sided? It doesn't. Okay, so you'd have to find those. If you turn to page 199 in your student journal, we're going to do some problems together. We're going to do 7 and 9 together. All right, so number 7, how many sides are there? 4. 1, 2, 3, 4. So what kind of shape is this?
Quadrilateral.
A quadrilateral. So you can do one of 2 things. We just talked about it. How many degrees fit inside of a quadrilateral? 360. If you don't remember that, that is fine. You would just use your n minus 2 times 180. Which you'd get the same answer, because 4 minus 2 is 2. 2 times 180 is still 360. So you can either remember it, or you could do this formula. So if you know all of the angles add up to 360, how can we solve for x?
Add them all up.
Yep. Add all 3 angles, or 4 angles up, and set them equal to 360. So I start with A. Doesn't matter which one you start with. 45. Plus 65, plus 95, plus x. You can be following along in your student journal. That's why you have it, not for me to do it, but for you to do it with me. And they all three equal 360 degrees. All right, so solving for x, we need to combine like terms. 45, 65, and 95 make 45, 65, 95.
205.
205 plus x equals 360. Subtract 205. And what does x equal? $155. Y'all take out your calculators. Get alive. Get alive. What? I do, Lucius. I actually do. Any questions on how we did that one? All right, so we're going to do number 9. It's right under it. How many sides are in number 9? 5. What kind of shape is 5-sided? Pentagon. Pentagon. Close, though. 5-sided. So you can plug it in the formula. 5 minus 2 times 180. 5 minus 2 is 3 times 180. How many degrees fit inside of this thing? 540. So, in your textbook or in your student journal, you're going to see the curve marks have X's next to them. When you get to do your classwork, they're not going to be there. You can write them there because what do curve marks mean in geometry like that? They're congruent. So if they're congruent and they're both missing, you can call them both X. They're already like that in your textbook, and that's fine, or your student journal. But they're not going to be like that for your homework, your classwork. All right, so all of these angles add up and equal 540. So I'm just going to start with letter A. What does that box mean? 90. And then I'm just going to go around clockwise. So X, and then 100, and then 70, and then X, and they equal 540. 90, 100, and 70 make 260. X and X make 2X, and they equal 540. All right, how do we continue to solve? Subtract 260. 2x equals 280. All right, do we have what x equals?
Yes.
Well, I don't. Divide by 2, and x equals 140. Boom. Questions, comments, concerns? Awesome. You guys are going to do this one on your classwork paper that you're going to turn in.
Oh, goodness. Why is it so noisy?
You will live. Marcellus, work on your paper. You're doing number 8 on your classwork paper. We're going to learn the last theorem. We have one last thing to do. If you look on page 198 at the very bottom in your student journal, this is the last theorem. What kind of angles are in this theorem? You literally just have to read it.
Exterior.
Exterior angles. So before, Kobe, when we had interior angles, if we found the interior sum, what did we have to do? How did you find the sum of the interior angles? Thank you. And minus 2 times 180. Well, guess what? Exterior angles are actually simpler than that. The exterior sum, it does not matter if it is a quadrilateral, if it is a 99-sided, whatever it was called. It will always equal 360. So if you want to write that, they always add up and equal 360. On our picture, there are 5 sides. In our example, there are 6. In your book, I think number 10, there's 4. It doesn't matter how many sides there are. What happens is when you kind of cut and paste them all together, they make a full circle, which is 360 degrees. Okay, so knowing this, very simple to solve, like the problem on our screen. Starting with 62, if you add them all together, 62 plus, you can read them to me, 35, 69, 41, 68, 58.
No, I was saying 58.
Oh.
58.
Y'all, I have to zoom in and out to write on this thing. Plus 5x, and what does it all equal? You don't know. It equals 360. I wasn't asking to add it. Just saying. Equals 360. Yeah, it is. Is this problem? No. This is, you see how it's that color? It's also an extra example. Alright, so, with a calculator, 62, 35, 69, 41, 58. What does it make? Pretty sure it's 260. Tell me if I'm wrong. Pretty sure it's 260. 265. There you go. I was close. Plus 5x. Alright, so how do we finish solving for x? Subtract 265, and we get 95 equals 5x. And then 95 divided by 5, x equals 19. It's okay. Any questions on this? Any questions? Awesome. You are doing number 10 on your classwork paper. Once you have finished, you can open up your textbook, page 364. 364.
You said 3 what?
364. Alright, so my other classes did not finish. Some of them did, but not all of them did. So in class, I will be checking 11 through 17. But you're doing 11 through 26. So make sure you at least get through 17. After that, you can keep going because we're checking it tomorrow. Does that make sense? So you're doing 11 through 26. Make sure you get at least through 17. Oh, I just deleted it. I'm writing it down. Yep. You see how it says classwork, right? I just underlined. This is still your classwork. So you're doing 11 through 17. That's what's going to be checked today. But you need also 18 through 26. So you're doing 11 through 26 overall. Let me freeze this screen for you. It's the same.